Hi guys, welcome to Homebrew Wednesday. Cheers. This is my latest incarnation of my Sierra Nevada Pale Ale clone. However, I've tweaked the recipe a bit and it's no longer really a clone because it's lighter in colour, it's dry hopped, and it's got a slightly different hop profile to it. But I guess it comes as an iteration from that recipe itself, so credit to that for the starting point. But yeah, it's very good. It's just come out of a keg, been in there just over a week and it's clearing now. There's still a bit of hop haze in there, but it's a really tasty beer. So, updates from me. It's been a while since, probably 3 weeks I think, since I've done a proper Homebrew Wednesday that's been planned at least anyway. And what's been going on? Well, I think probably my last proper one was brewing some of this. And obviously that's progress now to the glass, so that's successful. I've done another couple of brews since then. First one I did was an all grain beer. It was a bunch of leftovers really. I had a load of loose ends of pale malt, a bit of Munich, a bit of lager malt, a bit of pale malt, a bit of Golden Promise. So I chucked them all in, a little bit, I think those were the only grains, a bit of torrefied wheat for head retention. I got a bargain packet of Pacific Jade New Zealand hops from the Malt Miller, £1.50 for a bag of hops. I thought it was pretty good value. And I had a packet of SO4 kicking around, so I chucked all that in. Fermented it out, came down from about 10.50 to 10.13, 10.14, which isn't terrible I suppose for an English yeast. And it's currently in the keg on dry hops, so dry hops will be taken out in a few more days and give it a bit of time to clear and we'll see how that goes. The other bit of brewing I did was on Sunday, and on Sunday I finally got around to brewing my beer for this year's SJ Pour competition. So for obvious reasons, although, well, entries have now closed even in the UK, so I suppose I could tell you what I've done. Essentially it's a big hoppy imperial pale ale, so no surprises really, I guess. Working on label design, thinking of a name, those kind of things. But yeah, it's done, it's in the fermenter, and it was off like a rocket. The yeast I used really started off nicely, so hopefully it attenuates well and we end up with a nice dry beer. So moving on to other things, I suppose first thing I should do is thank fellow prolific brew tuber, Uncle Jonah. If you haven't seen him, where have you been? His channel is heavily populated with all sorts of content, brewing related and beer related and cider related. It's great. And the reason I'm thanking him is because he supplied the magnets for my Stirplate. And in exchange for that I sent him a couple of stir bars, because for my Stirplate build I decided to order a few different stir bars because they didn't cost very much, only a couple of quid each, so about $3 each, something like that. So I decided to order a few, and obviously I had some spares, and it just so happened that when Jonah and I were doing our builds, we were doing them at the same time more or less, and I was short of magnets and he was short of stir bars, so we made an arrangement, helped each other out, and we both completed our builds. So this is my build. As you can see, it looks a bit Heath Robinson. It's very basic certainly, but it really works. The philosophy I wanted to take with this was something that didn't take a long time, and it worked fine, and it didn't cost me much money. So I thought I'd show it, even though it does look a bit rough around the edges. Obviously I'm using one of these food containers, Tupperware type thing, for the case. 80mm computer fan stuck inside the lid. I've actually just cut a hole in the lid so there's no solid material between the magnets themselves and the bottom of the flask. The magnets are simply glued on with a general purpose adhesive onto the fan. As you can see, the stir bar sticks to them nicely. The fan is bolted through the lid using some just machine bolts, machine screws, whatever you call them. And I've used these on the surface of the lid, which are, you can buy them on eBay for sticking on the bottom of speakers for providing a bit of damping to your bottom of your speakers if they're on a flat surface that isn't quite flat. They're just little self-adhesive rubber stick-on pads, and I had a few kicking around, so I've used those. Inside, couldn't really be simpler. We've got the positive and negative leads from the fan going into a pair of terminal blocks, just like that, and then connected to the positive and the negative of my AC to DC adapter. Now, there isn't actually any speed control on this, and that was kind of deliberate, because in order to kind of get the most simple build possible, I decided to go and buy an AC DC adapter from RS Electronics, as you can see, and this particular one, it costs about £7 I think, actually has an adjustment on the back for different levels, different voltages. So you've got 1.5, 3, 4.5, 6, 7.5, 9 and 12 volts just at the flick of a switch there, and that adjusts the speed nicely. I found on this setup that 6 volts is fine. It gives you just about the right amount of speed with this particular stir bar. You can use it on 7.5, but it's probably a bit fast, it draws a bit too much of a vortex. And 9 and 12, it actually throws the bar, so I could probably position the magnets a little bit better on this and do other things to maintain it, but for me it works absolutely fine. Cost me less than £20 all in, so I'm stoked with that, and it works really well. And I actually used this to propagate a yeast starter to brew my SJ pour beer at the weekend, so it's seen its first use properly in anger, and appeared to work very well, so I'm really happy with that. It's not the prettiest thing in the world, but it certainly works alright. Okay. Right, the next thing I'd like to talk about is reusing yeast. Now, as far as I can tell, learning how to reuse yeast is an absolute minefield. And it's one of the reasons that I bought this book, which is Yeast by Chris White, who is the founder, I believe, of White Labs, and Jamil Zainasheff. I apologise if I have pronounced your name wrong. So, the main reason I wanted to get into reusing yeast was to save a bit of money. But in actual fact, in reading this book, it actually tells you that reusing yeast is not only a good way of saving money, but it's a way of getting the best quality beer, because laboratory produced cultures, which of course you buy from your homebrew shop, have not had time to bed in, for want of a better term. So what I thought I'd do is try something on here that I've never done before, so it may work, it may not, just to demonstrate a technique, and I'm sure it's just one of many, of reusing yeast, and also estimating the density of the slurry as well, because one of the difficulties when repitching yeast is how much to repitch. it's difficult to know how many cells you're repitching, and of course that's critical to the quality of the beer when you're making a new batch. You need to know how many cells you're putting into the wort to ferment it, to attenuate properly first of all, but also to get the proper yeast cell growth rate, which helps you to create the correct flavour profile. So what I've just done, I have here the yeast cake, which is from this beer in fact. I harvested this, it was about a week ago, so I don't know if I'm going to actually use this yeast or not, or if I'm just going to use it for the video purposes, because it's a week old. I refrigerated it for a week. You may have seen it on the table during the last part of the video, and during that time it separated into the solids and the liquid. I poured the liquid off, and I've just refilled it at the start of that section with water that I've boiled for about 15 minutes and then cooled down to room temperature. That's not absolute best practice, because what you should really do is use sterile water, and when I say sterile water I mean water that's been boiled for 15-20 minutes in a pressure cooker at higher temperatures than you can achieve just on the stove without the extra pressure. So this isn't ideal, and as I said, I might not use this yeast anyway, so it's mainly for demonstration. So I've poured the liquid off from this yeast cake, and I've just topped it up with the boiled water. So now what I'm going to do is mix this, or shake it I should say, until we've got all of the solids back into solution. And the idea is, when that's been done, this will then separate out again into a portion which contains mainly the true, I don't know how you pronounce that word, a portion that contains the yeast that you want to keep, and a portion that contains mainly water and the lighter kind of proteins that you also want to get rid of. So I'm going to cut the video here and start a timer, and we'll come back after a period of time when I think that kind of stratification has occurred, and we can then move on to the next stage. So, excuse the pint of foam, my kegging system is lacking refrigeration and a bit lively. So it's been about 15 minutes since I switched off. You can probably see several layers in this now. This top layer here is just foam, and I don't see any way of getting around that until, well, other than for leaving it for a long period of time, which I don't really have the opportunity to do. We've got another layer below the foam here, which is perhaps 5mm, something like that, and that is clearing. Mixture of water and beer. Then we've got this large layer of cloudy yeastiness, and then in the bottom there's clearly a layer of rubbish that we don't really want. So what I'm going to attempt to do is pour off this first layer, and I'll go to the sink to do that, so I will be off camera. And then I'm going to fill one of these bottles with as much of this middle layer as I can. And also I'm going to put a sample in this glass as well for the next part, which you'll see why in a minute. But these bottles, excuse me, these are old passata bottles, Italian sieved tomatoes, and the reason I use them is because they're glass, they're quite large, they go in the fridge relatively easily, and you can boil them up and get them pretty clean, sanitary for use. Obviously if I had a pressure cooker I could make them completely sterile, but I don't, so they're not. The other thing is the labels on these ones, I don't know what make they are, the labels on these ones, they come off in soapy water without leaving any residue, so when you're boiling it you're not going to get any residue inside the bottle, so that's why I use these. So I boiled a couple up earlier, and they're now completely cool. The lids have been sucked in because of the vacuum. So I shall go and pour this clear layer off the top and start decanting some of the middle layer into this bottle. Back in a sec. Okay, so that's the clear layer just about poured off, I think. We should hear a pop when I open this. There we go. Indicates a good seal. I have got a funnel sanitised, but I reckon I can do this without touching the sides. So I'm just going to go for it. So we're getting a nice, I'm going to stop midway and just take a sample in there and continue thus. Now, I reckon that's plenty of yeast slurry for another batch, so I'm probably going to discard this, and I'm not going to use this bottle because the significant other person in my family is sick enough of me taking up room in the fridge and freezer with brewing ingredients. So this is for the fridge. I'll do that in a minute. And that brings us to this. So this is our rinsed yeast slurry. Smells like beer, of course. It's quite a milky colour, obviously. It's fairly homogeneous. It's about the thickness of single cream, I would say. Now the problem with repitching this is it's easy enough to measure an amount of this slurry using any kind of measuring jug or something like that, but you don't know the yeast cell density in it. And one of the techniques that this book describes is a relatively simple technique to estimate the yeast cell density. And that is based on the simple fact that at a concentration of approximately 1 million cells per milliliter, yeast in suspension is not visibly turbid. So what that means is, if we perform a series dilution of this slurry, and we do it carefully, using measured ratios, we should be able to inch our way down to a point where the slurry is not visibly turbid, and we will then call that 1 million cells per milliliter. And then through calculation we can, because we've recorded the ratios at which we diluted, we should be able to determine the approximate, and I mean approximate, yeast concentration in this slurry. So that's the reason why I have a jug of water and my hydrometer test jar. In fact, and my hydrometer, we don't need that. So my hydrometer test jar has helpfully got a scale printed on the side of it, as you can see. So what I'm going to do is attempt to pour 10 millilitres of this slurry into here. And this is going to be messy. And obviously I'm working in a non-sanitary manner, so we are going to have a mess, and it's not going to be usable at the end. I'm just going to discard this star sand so that I've got something to put the dregs in. Right, sorry about that. So what I've got in there, I've managed to get about 14 millilitres, so I'm going to try and tip a little bit out and try and get to 10. So I'm now down to about 11. So I'm going to try and carefully pour off another one. I would say that's approximately 10 millilitres. I'm not being exact because this is definitely a very vague technique. So this is just regular tap water. I'm just going to pour some of it out so I can be a little bit more accurate about the pouring. I'm going to fill it up to the 100 millilitre mark. So we've diluted it 10 to 1. Obviously it needs mixing, so I'm just going to use my hand. So we've done a 10 to 1 dilution of that slurry, and you can see it's still pretty visibly turbid. So what I'm going to do now is try another 10 to 1 dilution. So I'm going to try and pour off 90 millilitres. I'm trying to be careful here that I don't pour off more than I need to, because it will be a problem if I did. Might have to start again. And that's approximately, perhaps 11. Let's just try and get another 1 ml out of there. Oh dear. So I've poured off a little bit too much, that's 9 millilitres. Which is going to make my calculation a bit more complicated, but let's press on. Now on the fly there, my brain did a very clever calculation, and with 9 millilitres, if I'm going to dilute it 10 to 1, I just need to fill it up to 90 ml, don't I? So that's what I did. So we've got another 10 to 1 dilution. So a 10 to 1 and a 10 to 1 is equivalent to 100 to 1 dilution, I believe. And it is still visibly turbid, but it seems like we're getting there. So what I'm going to do is try and remove 45 litres, so we're diluting it 2 to 1. Okay, we're just a little bit under 45, but I'm not too worried for the purposes of an experiment. So I'm going to go again and top it up to 90. So that's a 10 to 1, a 10 to 1 and a 2 to 1. So that's a 200 to 1 ratio that I've diluted it to now. And we are getting clearer, but we're still turbid. So again, I'm going to pour off half of it. And again, I've gone a little bit under, so I'm just going to make sure that I go a little bit under the 90 again when I top it up. So we've got now a 10 to 1, a 10 to 1, a 2 to 1 and a 2 to 1. So 10 to 1 at first makes it 10 to 1, another 10 to 1 makes it 100 to 1, the first 2 to 1 multiplied by 2, so 200 to 1, and another 2 to 1 makes it 400 to 1. And we are getting there. It's still turbid, but it's certainly getting much clearer. So maybe this will be the last step, I don't know, let's see, we'll try and do it again. So we're down to 45 again, and I'm going to top up to 90 again. for the final, well, perhaps the final one. So that is an 800:1 ratio. And I would say at that ratio it's more or less clear. Certainly I think I'd be comfortable with using that as my point of reference, because I'd rather overpitch a little bit than underpitch yeast. So 800:1. So assuming this is a million, if this sample is 1,000,000 yeast cells per milliliter, I have to multiply that by 800 to get my concentration of yeast cells in this slurry. So 800 million cells per milliliter. Now to me that sounds a bit low, to be honest. So I'm going to come back. Give us a second. So right, I'm a proud owner of the Mr. Multi pitching rate calculator app on Android, but I believe it's also on iOS and various other platforms. And that app gives you an estimation of the millilitres of yeast slurry needed based on a particular yeast concentration. Now unfortunately the concentration in this only goes down to 1 billion cells per milliliter. And we've just ascertained that this is approximately 800 million cells per milliliter. So I don't know if I've done something wrong, or maybe I just topped up too much with too much water in the slurry initially inside the bottle. But because an overpitch is probably better than an underpitch, I'm going to assume that this is actually, no sorry, that would mean an underpitch. These calculations are difficult. So the lowest yeast concentration I can get on this app is 1 billion cells per milliliter. So I'm going to set that at 1 billion cells per milliliter. There's also a slider bar for non-yeast percentage. I reckon I'm pretty low because I probably dropped out most of the trub when I did that. So I'm going to leave that at say 5%. Come on. And I'm going to say here I'm going to ferment an ale. The OG of my wort will be 1055, fairly typical ale, let's say a 19 litre batch, which is approximately 5 US gallons. This tells me that what I need is 192 billion yeast cells, or 213 millilitres of this slurry, or probably a little bit more than that of this slurry, because this we think is 800 million per mil. Wow, that was hard work. Anyway, I'm not going to keep you any longer. So, happy Homebrew Wednesday, and cheers.